Chapter Mechanical Properties of Fluid. Today we study or discuss the capillary action. Firstly, we define the capillary. Capillary means a tube having very small bore and this tube open at both ends is called capillary. कॅपिलरी म्हणजे एक खूप लहान अशी ट्यूब ग्लास मेड फ्रॉम ग्लास मटेरियल और ट्रान्सपरंट लहान ट्यूब त्याचं खूप असं लहान छिद्र अबाउट डायमीटर ऑफ दॅट बोर इज नियरली इक्वल टू 1 mm म्हणजे खूप असं लहान छिद्र असलेली ट्यूब आणि दोन्ही बाजूनी ओपन असलेली त्याला म्हणायचं कॅपिलरी. This is the definition of capillary. The tube having very small bore and open at both ends is called capillary. Suppose we consider glass and suppose this is liquid and this liquid is totally with the solid, that is water, and consider another glass or glass vessel containing liquid does not wet the solid, that is mercury. We consider two glass vessels. In figure A, there is liquid totally or partially with the water or solid. For example, water. And in second glass vessel, we take liquid, or which liquid does not wet the solid. For example, mercury and glass. Here water, and when such capillary tube is dipped in firstly water or liquid, this liquid is totally with the solid. In this case, the liquid rises into capillary tube. This is the liquid level, but when capillary is dipped in liquid or water, the capillary or water rises into capillary tube up to height h. And when the same capillary tube is immersed or dipped into liquid, that liquid does not wet the solid, for example mercury, then the liquid fall. This is the fall of liquid into capillary, or this is called capillary fall. And this is called capillary runs. म्हणजे जर अशी कॅपिलरी ट्यूब की जी दोन्ही बाजूनी ओपन आहे ती जर आपण वॉटर सोल्युशन मध्ये किंवा लिक्विड वॉटर असं त्याच्यामध्ये ठेवली तर ह्या ग्लास व्हेसलपेक्षा ह्या मर्क्युरी ट्यूबमध्ये कॅपिलरी ट्यूबमध्ये पाण्याची ही जी लेवल आहे त्याच्यापेक्षा जास्त पाणी उंचीवर जातं. याला म्हणायचं लिक्विड कॅपिलरी राईज और लिक्विड रायजेस इनटू कॅपिलरी ट्यूब. आणि ते जर आपण लिक्विड मर्क्युरी घेतलं तर ह्या ट्यूबमध्ये त्याची लेवल ग्लास व्हेसलच्या लेवलपेक्षा कमी होते. म्हणजे फॉल आपण त्याला म्हणतो. म्हणजे कॅपिलरी मध्ये ह्या लेवलपेक्षा कमी मर्क्युरी जातं. आणि दिस कन्सेप्ट इज कॉल्ड फॉल ऑफ लिक्विड इनटू कॅपिलरी और कॅपिलरी फॉल. Hence, when the capillary tube is immersed in liquid, we observe rise and fall of capillary. When the capillary tube is dipped in liquid, the capillary inside the capillary some liquid is rises or some liquid is fall. Such phenomenon of rise and fall of liquid inside the capillary tube is called capillary action. It's called capillary action or capillarity. The liquid rise or fall inside the capillary tube. That phenomenon, when this capillary tube is dipped in liquid, such phenomenon is called capillary action or capillarity. And there are two concepts. First, in case of liquid is totally with the solid, the capillary rise or we observe the capillary rise phenomenon. And in case of liquid does not wet the solid, we observe the capillary fall phenomenon. Now we discuss in detail this capillary fall and capillary rise. म्हणजे मर्क्युरीचं उदाहरण घेतलं तर कॅपिलरी मध्ये ह्या लेवल पेक्षा कमी लिक्विड जातं. का जातं? आणि वॉटर असेल तर ह्या लेवल पेक्षा त्याच्यामध्ये जास्त लेवल राईज का होते याचं आपण कारण शोधूया. नाउ वी डिस्कस इन डिटेल द capillary rise and capillary fall inside the capillary tube. Now firstly A, we discuss capillary fall. We consider a glass vessel and a capillary tube open at both ends is immersed or dipped into liquid, and that liquid is a mercury. Then we observe this is the plane surface. When the liquid is immersed into glass vessel, this is the liquid mercury, and this is the fall of mercury. Now we consider different points. Suppose we consider point A. This is suppose point B. Point C, and point D. आपल्याला डिटेल मध्ये पाहायचं की कॅपिलरी फॉल कशी होते त्यासाठी आपण काय केले ग्लास वेसल घेतली and in that glass vessel we use liquid. That liquid does not wet the solid, that is mercury, and when this capillary tube is immersed deep into liquid we observe the fall of capillary fall. Now we consider 4 points. Point A just above of this concave surface and inside tube. Point A कसा घेतला आपण this point A is just above concave surface and inside the tube. Now we consider point B is just below the convex surface and inside the we consider 2 points. A point above the concave surface inside tube, point B below the convex surface and inside the tube. Now point C above the plane surface and outside the capillary tube, and point D is just below the plane surface and outside the tube. We consider 4 points A, B, C, D as shown in figure. Also let PA, PB, PC and PD with the pressures at point A, B, C and D respectively. Let PA, PB, PC and PD with the pressures at point A, B, C and D. Now from figure we compare the pressures. Firstly, pressure PA and pressure PB. If we compare the pressure at point A and pressure at point B, पण याच्या अगोदर आपण शिकलो की कॉन्केव्ह साइडचा प्रेशर हा कॉन्व्हेक्स साइड पेक्षा जास्त असतो. The pressure at concave side is greater than convex side. Now this A is in the side of concave, hence the pressure at point A is greater than pressure at point B, that is PB. Therefore the nature of that surface, suppose this is the convex side because this is the mercury, the nature of the concave pressure is greater than convex pressure, but this side is convex, and this side is concave. Therefore the PB greater than PA. The pressure at point, this point is B point, B is greater than point A because the concave pressure is greater than convex pressure, and this is the plane surface. Also, secondly, if we compare the pressure at point A and pressure at point C, that is pressure PA and pressure PC, the both pressure is above the surface of liquid, hence there is pressure called atmospheric pressure, and atmospheric pressure at point A and at point B is same, hence PA is equal to PC. And number 3, if we compare the pressure at point C and pressure at point D, that is PC and PD. But we know that the pressure at plane surface, आपण अगोदर शिकलेलो की प्लेन सरफेस असेल तर वरचा प्रेशर आणि खालचा प्रेशर सारखा असतो. मग इन केस ऑफ प्लेन सरफेस pressure of both sides above and below is same, hence PC is equal to PD. From 1 and 2 we can write PA is equal to PC is equal to PD. Therefore, pressure PB greater than PA. Now we observe the pressure at point B and pressure at point D. We compare the pressure at point B and pressure at point D. If the PA is equal to PC is equal to PD, then it is clear that PB is greater than PD. The pressure at point B is greater than pressure at point D. म्हणजे जो पॉइंट कॅपिलरी मध्ये आहे आणि लिक्विड मध्ये आहे त्या पॉइंटचा प्रेशर बी या ठिकाणचा डी जर पॉइंट इथं असेल किंवा इथं असेल, म्हणजे हा जो बाहेरचा भाग आहे ट्यूब मधला, ग्लास ट्यूब मधला जो प्रेशर आहे तो बी पेक्षा कमी असतो, म्हणून दिस लिक्विड फॉल and the level of that liquid inside the tube is fall, because the pressure at point B is greater than pressure at point D. This concept, due to this reason, the capillary fall inside the tube. Now we similarly discuss the capillary rise. Instead of fall, capillary rise. We consider the example, same example, but instead of liquid that does not wet the solid, we consider liquid is totally wet the solid. That is example of glass, and this is suppose water. This is the plane surface, and the liquid rises into tube up to height suppose h. This is the, again we consider 4 point A, B, C and D. Again we consider point A, B, C and D. This is the concave nature. Also we consider the point A is above the concave surface and inside the tube. Point B below the convex surface inside the tube. Point C above the plane surface outside the tube, and point D below the plane surface and outside the tube. Also PA, PB, PC and PD with the pressure at point A, B, C, D respectively. Now firstly we compare pressure at point A and pressure at point D. The pressure at point A, that is, this is the concave side and this is convex side, hence the pressure of concave side is greater than pressure at convex side, that is PA greater than PB. Now secondly, if you compare pressure at point A and pressure at point C, both are in air, hence there is atmospheric pressure, the PA is equal to PC. Third point, the pressure at point C and pressure at point D, these two points above and below the plane surface, the pressure is same, hence PC is equal to PD. Now we compare the pressure at point B and pressure at point D. From this equation 2 and 3, PA is equal to PC is equal to PD. Hence PA instead of PA, PB, and if we compare the pressure at point B and pressure at point D, we observe that the pressure at point D is greater than pressure at point B. In case of mercury, the pressure at point B is greater than pressure at point D, but in case of water, the pressure at point D is greater than pressure at point D. Hence, the liquid rises because the outside pressure of tube inside this liquid is greater than inside. Hence, the liquid rises into capillary tube, up to which the pressure of B is equal to pressure of D. Pressure बाहेरचा प्रेशर या ट्यूब मध्ये जो पॉइंट आपण घेतलाय B, या ठिकाणचा प्रेशर हा D ठिकाणापेक्षा कमी असतो, किंवा जो D आहे म्हणजे D पॉइंट कुठे आहे ग्लास मध्ये आणि वॉटर मध्ये आहे, हा बाहेरचा प्रेशर कॅपिलरी पेक्षा जास्त असतो. म्हणून बाहेरचा प्रेशर जास्त असल्याने प्रेशरने काय होतं, या कॅपिलरी मध्ये पाणी वरती जातं अप टू हाईट एज, आणि कधीपर्यंत हे लिक्विड राईज होतं जोपर्यंत प्रेशर ॲट पॉइंट डी अँड प्रेशर ॲट पॉइंट डी हे सेम होत नाही किंवा इक्वल होत नाही. म्हणून in case of water and glass, the capillary rise, we observe the capillary rise phenomenon, or we observe the rise in liquid in capillary tube. Or in case of mercury, the inside pressure, that is pressure at point D is greater than D, pressure at point D, hence the liquid fall. This is the phenomenon of liquid rise and liquid fall. This is the first method. Now we discuss second method of capillary rise called using force concept or force due to surface tension. Now we consider the capillary, and this capillary containing the liquid. Now, in such a case, suppose this is center or radius, and this is suppose height h, the capillary rise, or that is called liquid column, and h is the height of liquid column, and r is the radius of that capillary tube. Now, the total weight of that liquid column acting vertical downward. The two force acting on that liquid column, the first is its weight acting vertical downward, and secondly the force due to surface tension, the force due to surface tension is suppose Ft, and T is the surface tension of liquid. The another force acting on that air column is the Ft, that is force due to surface tension acting vertical upward and make some angle, that is theta. That theta is called angle of contact. Theta is called angle of contact between solid liquid interface. Now this Ft is resolved into two components. First component is called Ft cos theta, and second component is along the center, that is Ft sin theta. Here also Ft cos theta and Ft sin theta. This Ft, force due to surface tension, is resolved into two components, Ft cos theta and Ft sin theta. But Ft sin theta is cancelled with each other, and Ft cos theta as acting vertical upward. Now we find out the liquid rises into capillary, the total upward force and total downward force is equal. त्या कॅपिलरी ट्यूब मध्ये जे लिक्विड राईज होणार आहे ते स्थिर कधी राहील की जोपर्यंत त्याच्यावर वरच्या बाजूचा फोर्स आणि खालच्या बाजूचा फोर्स सेम असणार आहे. Now we calculate the total upward force and total downward force. The total upward force, is Ft, that is force due to surface tension of liquid, is equal to surface tension of liquid into length of liquid, that is length of liquid means that is circumference of circle. Circumference of circular part of that liquid column. This is nothing but Ft is equal to surface tension is T and circumference, that is 2 pi r. But this T is resolved into two components, Ft cos theta and Ft sin theta. But sin theta is cancelled. There is Ft is equal to, instead of F we can write T cos theta into 2 pi r. This is the upward force. This is the total upward force, equation number 1. And total downward force. Total downward force is its weight acting vertical downward. But W is equal to mass into gravity, and the mass of that air column, this liquid column of height h acts as a shape of that is cylinder. ह्याच्या कॅपिलरी ट्यूब मध्ये जे लिक्विड कॉलम आहे h एवढ्या उंचीपर्यंत, हा आपल्याला सिलेंडर सारखा दिसतोय. म्हणजे मास आपल्याला सिलेंडरचं करावं लागेल. मास इज नथिंग बट व्हॉल्यूम इनटू डेन्सिटी. मास इज रिझॉल्व्ड, or using definition of mass, volume into density. Now we determine volume of that cylinder. W is equal to volume pi r square h rho into g, where h is height of that column. This is the total weight, pi r square h rho g. This is the total downward force. Now the total downward force is equal to total upward force. Total downward force is equal to total upward force. Therefore, T cos theta into 2 pi r is equal to pi r square h rho g. Therefore, 1 r cancel, pi cancel. Therefore, 2t cos theta is equal to r h rho g, or h is equal to 2t cos theta divided by r rho g. H is equal to 2t cos theta upon r rho g. Using this formula, we calculate the height of liquid column, or we calculate the liquid rise into capillary tube up to height h, and that height h can be determined using this formula. And also we rearrange the term t is equal to r h rho g divided by 2 cos theta. Using this formula, we calculate the surface tension of any liquid. T is equal to r h rho g upon 2 cos theta, where T is surface tension of given liquid, r is radius, h means height of liquid, rise, rho is density of given water or liquid, g is acceleration due to gravity, and theta is angle of contact between solid and liquid interface. In case of water, in case of, suppose this liquid is water, then the angle of contact for water is 0 and cos 0 is equal to 1. Hence, surface tension of water, we can write TW is equal to RH rho g upon 2. Also, in case of water, the density is 1, therefore T water is equal to RH upon 2. Using this formula, RH rho upon 2 determine the surface tension of water, that is TW is the surface tension of water, RH rho upon 2.